Okay, so this is the quick review of a distance and midpoint, and we're really talking about 3 dimensions. So you can see I have a 3D plane in front of me. Notice the x-axis is supposed to be coming straight out at you, but we have to draw it at an angle because we have to try to draw 3 dimensions on a 2-dimensional surface. So technically it should be coming right out at you, but this is all we can do to make it give that right effect. Notice the y seemingly goes left and right. I would have kept that x, but I'm not the one that decided how it was going to go. And the z goes up and down. Again, I would have made that the y, but it wasn't my choice. All right, we have x, y, and z planes. So you can notice the coordinates of this first point are 1, 2, 1. And I tried to show you where that came from. If you go down vertically and then horizontally over, you hit 1 on the x. If you then go by the same angle, right, as the x-axis, you hit 2 on the y. And if you go up and follow that same, that's a little trickier on that angle. You have to make a 3-dimensional box and you'll get a 1 for a z. Okay, but we have 2 points here, and we can find the distance between those 2 points, and we can find the coordinates of the midpoint. Okay, so formulas. There's the distance formula. Just like if it were in 2 dimensions, only you add a third z dimension. Okay, so that's pretty easy. Let's go ahead and do this. And we'll call the top point, point 2, and we'll call the bottom point, point 1. Okay, so the x-coordinate of point 2 is a 2, minus the x-coordinate of point 1, which is a 1, that quantity squared. The y-coordinate of point 2 is a 4, minus the y-coordinate of point 1, which is a 2. And again, no matter which one you call point 1 and point 2, it'll work out. It'll just be negative and negative or the positive aspect, but you're squaring it. And then we have a 5 minus 1 quantity squared. Okay, so where in the world are we at? This is a 1, so 1 squared is 1. This is a 2, so 2 squared is 4. This is a 4, so 4 squared is 16. So what do we have? The square root of 21. Hey, what's the distance between those points? The square root of 21, what is that? Somewhere around 4 point something, right? 4 point something. So we found the distance. And again, it's just the distance formula. How would we find the midpoint? We're just going to use the midpoint formula, right? So if you remember, the midpoint formula is the sum of the x coordinates divided by 2. You're finding their average, right? The sum of the y coordinates divided by 2. You're finding their average. And the sum of the z coordinates divided by 2. You're finding their average. And so you're getting the coordinates of the midpoint. Okay, so what do you have? 1 plus 2 divided by 2. 4 plus 2 divided, it doesn't matter which one you put first or second. I did that one backwards, doesn't matter. 1 plus 5 divided by 2, right? The x's divided by 2, the y's and the z's. So we end up with 3/2 would be the x coordinate. 3 would be the y coordinate, right? 6 divided by 2, and 3 again for the z. So 3/2, 3, 3 is the coordinates of the midpoint, the point halfway between those 2 points. Where would it be? Well, somewhere about there visually, which technically would have the coordinates 3/2, 3, 3. 3D, you can do it. You can find the distance, you can find the midpoint. That's a whole lot easier. Gets a little tricky, but a little bit of practice, you can figure out how to graph them as well. But that's the idea and that's the concept. All right, that's it.